A lot of students, I put this on the test or quiz, a lot of students miss this one. It's something like this. 4, let me think here, cosine cubed of 5x. But I think what happens to students, some students don't really understand what I've got written here now. Why? So maybe I'll help you if I write this, because here's what this means. Well, let me ask you this. Who's being cubed here? Who's being cubed? Okay, actually not the 4. Yeah, but who is? So who's being cubed? The cosine function. The cosine of 5x. Yeah, cosine of 5x is a function and it's being cubed. And when it's being cubed, maybe you think we should write that like this. Maybe you think, well, why don't you write cosine of 5x and then it's being cubed? Well, that's cool. You're right. That is how it should be written, I suppose. But with trig functions that are being cubed or squared, or we got this notation. We can do this. So this means this. But that might help you, because now you see a function within a function within a function, maybe. I mean, this is a 3-layered chain rule, I think. Because, let's see, I think the outermost function is I got some crap cubed. Inside there, I got a trig function called cosine. Inside there, I got a little baby 5x. You see that like that? I mean, if you see the layers of the chain rule, the function within the function within the function, it sure helps. So if I want to do this derivative, I'm going to bring the 3 down like a power rule. To me, it's a power rule, right? Something cubed. So you bring the 3 down, it's 12 times something squared. What is that something that's squared?
5.
The cosine of 5x. Yeah. See, that was just a power rule. The other mistake students make is they go try to do the other derivatives too early, the other links in the chain too early. So the first thing you do is just the power rule. 12 times that junk squared. Now, you're done with the power rule. Forget the cubed, forget the squared. Now you're doing the derivative of cosine. And it's multiplied out here. What is the derivative of cosine? Negative sine of 5x. So it's multiplied, which again, sometimes that screws students up because you're multiplying by a negative number. But anyway, this is not subtraction. It's multiplication. Parentheses might help you. The derivative of cosine is negative sine 5x. Okay, we're not finished. Now we got to do the little derivative of the little 5x. 5. It was a 3-layered chain rule. Like a 3-layered cheesecake. Not exactly. A function within a function within a function.
That 5 that you're multiplying out, right? Does that indicate like the cosine of 5x shoots out of 5 and also the sine of 5x within the chain rule? Like both of them, or
it's really one time.
Oh, okay.
The first thing I'm doing is I'm doing the derivative of something cubed. So I bring the 3 down, and that crap is squared. So that's just, can you handle that normal? That's just a good old power rule. And whatever the base was, whatever that thing that was cubed is, now it's that thing squared. You don't start doing the derivative of him too early. Write him down. He was cubed, now he's squared. I mean, you did a power rule on him. Now, forget the powers. You go, because now you're going inside the powers, and now you're doing the derivative of cosine. So what's the derivative of cosine? Bam. There it is. Negative sine 5x. I mean, it's a cosine of 5x, so his derivative is the sine of 5x. And now you're finally doing the derivative of the little 5x. And I guess it's that 5x that you're doing. You could say it's that one, but now you're doing the derivative of the innermost thing, the 5x, and what does that do? Spit out a 5. I mean, I'm trying to explain it, right? That's what I'm doing. I'm explaining it. I mean, I could just write, here, y'all got it. Read the damn rule. But I don't, you know, I'm trying to explain what the rule is. I'm trying to explain the inside function within another function. And anyway, I'm trying. But really, you got to go work with it. You know, that's really what I mean, listening to my explanation helps. But now you got to work with it. So it's done. The derivative's done. It was a 3-layered chain rule. Can we clean this up? Do you know what, I mean, can you, this is, sometimes I'm worried about this part here. I mean, everything's multiplied, so there is no real factoring on this thing, right? I mean, everything's just one big multiplied glob, and it helps to put the 5 and the 12 together and call it 60. Can we take the negative sign out front and call it negative 60? Cosine squared, that's what that is. I'm going to write cosine squared of 5x times a sine 5x, right? That's what I took the negative and the 5 and the 12 and grouped them together, and that's kind of all I did out there. Multiplied them out front.
You wouldn't change the cosine to negative because you factored out a negative sign?
So I didn't really factor out a negative sign. This was one multiplied thing, and I slid the negative sign out front.
Okay.
It wasn't factoring, it was reassociating. See, what I got here is it's like when you have 12 times 5 times negative 1, you can multiply things in any order. So I can write negative 1 times 12 times 5, or I can write, I don't know, it's kind of like that, I guess.
Yeah.
I like those. Do you like those?
I have one quick question.
Go ahead.
All right. So, remember when you said that the sine of 5x, right? How it shoots out of 5?
Uh-huh.
How come you didn't do that for cosine of 5x?
Well, I know.
Or what were we doing?
I know. So I think I want to refer to this.
Okay.
And I want to do 3 derivatives, I guess. I mean, the first derivative I want to do is I got 4 times, you know, maybe you could call this an x cubed or a u cubed. Sometimes they use the letter u. But when it's a function itself, I mean, it's a function. So anyway, I got 4u cubed. So how do you do the derivative of 4u cubed? You bring the 3 down, and it's 12u squared. All right. So anyway, so I'm done. Now I'm done with the power rule. So now I want to do the derivative of this thing, which is, I'm calling my u. Anyway, it's the cosine of some stuff. How do you do the derivative of cosine of some stuff? There it is. And now I want to do the derivative of the stuff, the little 5x. So what's that? 5. So I think I'm referring up to here. I'm doing the power rule on this guy, bam. Multiplied by the derivative of what's inside the power rule, bam. Multiplied by the derivative of what's inside that trig function, bam. So maybe you should refer to this when you do this chain rule, instead of referring to the stuff that's here, perhaps. Perhaps. Here's one of my favorite problems. You ready? Yeah, this is good. You ready? This is awesome. So this is awesome. I'm going to help you do this. Perhaps let's just do a little rewriting. We know what that is, but I want to just rewrite this. This is a 4x times, instead of writing that as a square root, I can write it as 3x squared plus 1 to the 1/2. Okay. We all do that, I guess. So now, there it is. So now I want to do the derivative. I want to do the derivative, and can you talk just a little strategy to me?
4 times the quantity 3x squared plus 1, 2.
I mean, what's the word for this? What are you going to do? Okay, it's a
Product.
product. Thank you. I just want to hear the word. Thank you. It's a product. We're doing a product rule. I wanted you to say that instead of me, but you're right. It's a product. We're going to do a product rule. So here we go. The derivative of the first two.
4.
Easiest thing in the world. And then what? After we do the derivative of him, what do we do with him? We just write him down. We just write him down. So I guess you should get partial credit for that, but I don't feel like giving you much. But anyway, you took that derivative and you wrote him down. Good job. Now what do I do? Write him down. Okay, I like to write him down. And now I want to do his derivative.
Right.
And his derivative is going to require a little chain rule. Not too terrible, but a little chain rule, right? His derivative. Because it's something to a power. So how do you do something to a power? You do 1/2 times that crap to the negative 1/2. That's the power rule. That's the power rule of something to the half. Now that you're done with the power rule, you go inside, forget the power, you go inside here and you got to do the derivative of the inside stuff, which is 6x. So it spits out a 6x. That's the chain rule. Overall, this was a product rule. But when I got to the part that said do his derivative, it was a little chain rule. Wasn't very terrible chain rule. 1/2 this crap to the negative 1/2 times the derivative inside. How you guys doing? You want to ask me anything? The derivative's done. The derivative's done. But this is this cleaning up that we almost started today with this cleanup, and here it is in a little more sophisticated way. I mean, the best way to clean this up is to do some factoring. You have you have this term and you have this term. And I want to factor out that big glob of crap, that big 3x squared plus 1. Here it is to the half, and over here it is to the negative 1/2. Which one do you factor out? The lowest one. So I'm factoring out, by the way, you could factor out a 4 also, couldn't you? You want me to do that? All right, I'll do that. I'm factoring a 4, and I'm factoring a 3x squared plus 1 to the negative 1/2. Okay, here we go, guys. I'm factoring that out of here. Okay, that means I just factored the 4 out of here. So it's gone. And I factored a 3x squared plus 1 to the negative 1/2 out of 3x squared plus 1 to the positive 1/2. That leaves me with, well, 3x squared plus 1 to the 1. Yes. Okay, good. That's what you were saying.
Yeah.
You guys with me?
Yeah.
When you factor 3x squared plus 1 to the negative 1/2 out of 3x squared plus 1 to the 1/2, you're left with 3x squared plus 1 to the first. If you don't believe me, multiply it back, add exponents, and what do you get? You get that. When you multiply it back and add exponents, you get that. You gotta add fractions. You gotta know how to add fractions. Negative 1/2 plus 1 is a 1/2. That's so awesome. Plus, over here, what's so awesome is you just factored that big nasty thing out of there. He's gone. He's gone. What's left over here? The 4's gone too, by the way. What's left over here? Well, an x, a half, and a 6x. That's actually going to be a 3x squared, 3x squared. You guys see that? 6x squared times a half. The 4's factored out. This thing's gone. I'm left with a 3x squared. Dude, I'm talking about, see what I love about this is the most efficient way to clean this up. You can do other algebra, but it'll take you 4 or 5 steps with what I just did in one smooth, cool, efficient step here. I mean, what's left is to clean this up, and can you tell me what that is? Because this is to the first, you don't write this to the first. Because you can add that crap up. What is that? What is that?
Squared plus 1.
Thank you. 6x squared plus 1, right? 6x squared plus 1. Listen, there's a 4 out front. And then what am I going to do with this guy right here? See him? What should I do with him? Move him to the denominator. I like that idea. I'll move him to the denominator, and he'll be a square root in the denominator. Ta-da! That's awesome. I love that problem. I love that problem. I love that problem. I call these medium to hard problems. They show up on tests. They're good. They really show whether you know these rules, kind of. I mean, they're good. Not only do you know your rules, but you know how to do some algebra to clean them up. Okay. I'm going to tell you this, that one thing that happened in 3.3 that I was anxious to get to the chain rule today and teach you this chain rule. So, but let me back up. And there's still some stuff way back in 3.1 I might need to talk about someday. I'll save that for next week. But you can do plenty of 3.2 homework and 3.3 and 3.4 now. Okay, you can do that. But one thing that happened in 3.3 that I glossed over, never got to, was after they taught me the product rule and the quotient rule, they went ahead and taught me the derivative of the other 4 trig functions. So hang on, we know the derivative of sine and cosine. What's the derivative of sine x? Cosine x. What's the derivative of cosine x? Negative sine x. Good. So we learned those two back in 3.2. In 3.3, they tell me the other 4. I'm going to show you what they are. The derivative of, and I guess I'm not going to prove it to you, but the derivative of tangent is secant squared. The derivative of tangent of x is secant squared of x. I mean, it's just a thing to memorize. If you want to understand why it is, then I got to give you some more explanation. But if you just have faith, you just memorize that. By the way, there's just a slight pattern to what's going on here. The derivative of cotangent is cotangent x is negative cosecant squared x. So it's sort of a similar pattern here. Let me show you the other two. The other two are the derivative of secant. The derivative of secant of x is secant of x times tangent of x. It's true. These are the other, there's 4 other trig functions. Tangent, cotangent, secant, and now here comes cosecant. The derivative of cosecant is negative cosecant x cotangent x. I'm going to write down the other two. Hang on, we already knew the other two. The derivative of sine was cosine, and the derivative of cosine was negative sine of x. Right, you guys? So there they are, all 6 trig functions. We should memorize those. If you want some proof of why these are what they are, I'll tell you something. Like tangent x, did you know you should know a little trig, you should know some identities. Did you know tangent is sine over cosine? So if you wrote tangent as sine over cosine, and then went and did a quotient rule on it, sine over cosine, that would prove to you, and you have to do some cleaning up and use some identities, but a quotient rule on sine over cosine would prove to you that that's the answer to tangent. So there are kind of ways to prove these using identities. But I don't know if proving them is that important. It's not that important to me. Knowing them is kind of important, though. Do you sort of see a pattern here? I mean, one little pattern of note is that there's 6 trig functions. You know, there's sine, cosine, tangent, cotangent, secant, cosecant. All the co-ones, the cosecant, the cotangent, the cosine are all negative. See that? The co-ones have those negative signs. The other ones have the positive signs. And then there is this similarity. Secant is secant tangent, cosecant is cosecant cotangent. It's got this negative sign. And this, so there's a little bit of similarities, and I don't know, it might help you organize your thoughts and memorize these things. Patterns. You look for patterns to help you memorize, I guess. So now we know the 6 trig functions. Look at that, 6 trig functions. we know a lot about algebra because we can do product rules and quotient rules and chain rules. Dude, we are really good now. Hang on. Do we know about the e function? Do you know the rule for the e function? The derivative of e to the x is e to the x. We did learn that one. So that's the one. Okay, here's one we didn't learn. I'm not sure where this shows up, but here it is. Finally, I'm saying natural log x. The derivative of natural log x is 1 over x. So there's one more for you to memorize. But that's it. There ain't no other functions. You don't seem as happy as I am. There's 6 trig functions, there's an e and a log, and then there's all kinds of algebraic crap. And then, of course, we can mix them all together, like we had an e times a sine, or we had, you know, we can. But that's it. There's 6 trig functions, there's these 2 guys, and then there's x squareds and x cubes and square roots of x, and, you know, there's algebra. And then there's these. All right.